Loch Ness is far more than a scenic Scottish lake. Stretching nearly 23 miles in length and plunging to an incredible depth of around 755 feet, it is the second largest freshwater lake in Scotland by volume. So vast is its capacity that it holds more fresh water than all the lakes in England and Wales combined. Beneath its calm, dark surface lies another extraordinary feature. It sits directly on the Great Glen Fault, a massive 62-mile geological fracture that slowly reshaped Scotland over hundreds of millions of years. This dramatic origin has created one of the deepest and most mysterious lakes in the British Isles. Its unusual geology is only part of the story. For almost 15 centuries, Loch Ness has been linked to reports of an unexplained creature lurking beneath its waters. The earliest known account dates back to around 565 AD, when the Christian missionary Saint Columba was said to have encountered a terrifying beast in the nearby River Ness. Over the centuries, similar stories continued to surface, passed from one generation to the next. Most people dismissed them as myths and local folklore, until the 20th century changed everything. In May 1933, Aldi and John Mackay claimed they had witnessed a gigantic creature thrashing across the surface of Loch Ness. Their story, published in the Inverness Courier, captured international attention almost overnight. Suddenly, the quiet Scottish lake became the center of one of history's greatest unsolved mysteries. A year later, the now famous surgeon's photograph appeared to show a long-necked monster rising from the water. Decades later, investigators revealed it had been an elaborate hoax involving a toy submarine fitted with a fake neck. Yet by then, the legend had already spread across the world. Since that moment, researchers have remained divided between two competing explanations. One group believed a real, undocumented animal inhabited the loch, perhaps a giant eel, an unknown aquatic species, or even a prehistoric survivor like a plesiosaur. The other side argued that every sighting could be explained by floating logs, waves, optical illusions, swimming animals, or the human tendency to mistake ordinary objects for something extraordinary. For nearly 90 years, these two ideas dominated every serious discussion about the Loch Ness mystery. Everything changed in 2018 when an international research team, led by Professor Neil Gemmell from the University of Otago, approached the mystery from an entirely different angle. Instead of hunting for the creature with cameras, boats, or sonar, they focused on the water itself. Scientists collected samples from roughly 250 different locations throughout the loch, taking them from multiple depths and regions. Their goal was to search for environmental DNA, tiny genetic traces that every living organism naturally leaves behind in the water through skin cells, scales, waste, and other biological material. The results of that massive DNA survey, combined with years of follow-up research using advanced acoustic sensors and geological monitoring along the Great Glen Fault, began painting a picture that was unlike either of the traditional theories. Rather than confirming a prehistoric monster or dismissing every report as imagination, the scientific evidence suggested a far more complex explanation. The mystery of Loch Ness may indeed have a real foundation, but not in the way generations of people expected. To understand why this groundbreaking research matters, we must first set aside the legends and tourist stories. Before Loch Ness can be understood as the home of a mystery, it has to be understood as what it truly is: an extraordinary geological lake with unique physical conditions that make it unlike almost any other body of freshwater in Britain. Only then does the evidence begin to reveal what may actually be hiding beneath its dark, silent waters. The loch sits in a geological wound. The Great Glen Fault is one of the largest and most active tectonic structures in the United Kingdom. It runs for 62 miles across the Scottish Highlands from Inverness in the northeast to Fort William in the southwest, cutting a diagonal slash through terrain that has been geologically active for over 400 million years. The fault is not dormant. Microseismic activity is recorded along the Great Glen regularly. The rocks on either side of the fault have been displaced laterally by approximately 65 miles over geological time. The northern highlands have slid southwest relative to the southern highlands at rates measured in millimeters per century. The loch itself was carved by glaciers following the fault line during the last ice age. The glaciers exploited the weakness in the bedrock, gouging a trench that would eventually fill with meltwater to become one of the deepest freshwater bodies in Europe. The depth is significant. Loch Ness reaches 230 meters at its deepest point, over 750 highs ft. The average depth is approximately 130 meters. The total volume of water is approximately 7.4 cubic kilometers, more fresh water than every lake in England and Wales combined. The depth creates conditions that are almost unique in British waters. Below approximately 100 meters, the loch enters a zone of permanent darkness. No sunlight penetrates. The temperature hovers around 5 to 6 degrees C year-round, regardless of surface conditions. The pressure increases with every meter of descent. The water itself is dark. The loch's watershed drains extensive peat deposits. The water that flows into Loch Ness carries dissolved organic compounds that stain it brown, the same compounds that give Scotch whiskey its color when aged in barrels. Underwater visibility in Loch Ness is typically limited to a few feet. At depth, visibility approaches zero. This is the environment that has sustained the mystery. A creature could exist in Loch Ness without ever being clearly observed, surfacing rarely, staying deep, moving through water so dark that even sophisticated imaging technology struggles to penetrate it. The depth, the darkness, the volume. These are the physical conditions that have made the Loch Ness Monster plausible for nearly a century, and these are the conditions that the environmental DNA survey was designed to circumvent. The legend predates the modern phenomenon by over a millennium. Saint Columba was an Irish missionary who brought Christianity to Scotland in the 6th century AD. He founded the monastery at Iona and spent decades converting the Picts, the indigenous inhabitants of northern Scotland, to the new faith. Around 565 AD, according to Adomnan's Life of Saint Columba, which was written approximately a century after the events it describes, Columba encountered a water beast in the river Ness. It was not the loch itself, but the short river that connects the loch to the Moray Firth. The account describes a creature that had attacked and killed a man. Columba commanded one of his followers to swim across the river. When the beast rose to attack, Columba made the sign of the cross and commanded the creature to retreat. It obeyed. The story is hagiography, a saint's life written to demonstrate divine power. It follows conventional patterns of such literature in which holy men command nature and overcome monsters through faith. But it is also the earliest written reference to something unusual in the waters near Loch Ness. The Columba account did not create the modern phenomenon. It sat in ecclesiastical archives for over 1,000 years, known mainly to scholars of early medieval Christianity. But it established that the association between Loch Ness and anomalous creatures predates the 20th century by more than 300 years. The pre-Christian context is equally significant. Scottish Highland folklore includes extensive traditions about water spirits, beings that inhabited lochs, rivers, and coastal waters throughout the region. The Kelpie is the most famous of these figures, a shape-shifting creature that could appear as a horse or a human, and that lured travelers to their deaths in the water. Kelpie stories were told across Scotland. They were not specific to Loch Ness, but they established that the cultural infrastructure for believing in water monsters existed in the Highlands long before St. Columba arrived and long before the modern Nessie phenomenon began. The people who lived along the shores of Loch Ness had been telling stories about things in the water for generations. What changed in 1933 was not the stories. What changed was the audience. The A82 road along the northern shore of Loch Ness was completed in 1933. Before the road, access to the loch was difficult. The terrain was steep and the shoreline was rugged. Communities along the water were small, isolated, and largely invisible to the broader world. The new road changed everything. For the first time, travelers could drive along the length of Loch Ness with clear views of the water. Tourists from England and beyond could visit the Highlands without the logistical challenges that had previously limited access. The loch became visible to people who had never seen it before. On April 14, 1933, a couple named Aldi and John Mackay were driving along the newly completed road when they observed something unusual in the water. They described an enormous animal rolling and plunging in the loch. a disturbance that lasted for approximately a minute before the creature submerged and disappeared. The Mackays reported their sighting to Alex Campbell, a water bailiff and part-time journalist who contributed to the Inverness Courier. Campbell published the account on May 2, 1933. The article used the word monster. Within weeks, additional sightings were reported. Within months, the story had spread to national newspapers. By the end of 1933, Loch Ness had become an international sensation, the subject of expeditions, newspaper features, and a public fascination that has never entirely subsided. The timing was not accidental. The early 1930s were a period of intense public interest in exploration and discovery. The golden age of Egyptology was recent memory. Expeditions to remote regions of Africa and South America were still returning with reports of unknown species. The idea that large creatures might remain undiscovered in remote locations was not considered absurd. And Loch Ness was remote. The combination of a deep, dark lake in the Scottish Highlands, newly accessible to mass tourism, and sighting reports arriving at the exact moment when the public was primed to believe in undiscovered monsters, created the perfect conditions for the phenomenon that followed. The surgeon's photograph crystallized the image. On April 21, 1934, the Daily Mail published a photograph purportedly taken by Robert Kenneth Wilson, a London gynecologist. The image showed a long-necked creature with a small head breaking the surface of the water, the iconic silhouette that would define the Loch Ness Monster for the next 60 years. Wilson refused to have his name associated with the photograph, which only added to its mystique. The image was referred to as the surgeon's photograph. Its anonymous provenance suggested a respectable medical professional had captured evidence so controversial he could not publicly claim it. The photograph was reproduced thousands of times. It appeared in newspapers, magazines, books, and eventually television documentaries. It became the definitive image of the Loch Ness Monster, the visual proof that something was in the water. For 60 years, the photograph anchored the mystery. In 1994, it was exposed as a hoax. Christian Sperling, on his deathbed, confessed that he had helped create the image. The monster was a toy submarine purchased from a local shop, modified with a sculpted head and neck made from plastic wood. The photograph had been staged by Sperling's stepfather, Marmaduke Wetherall, a big game hunter who had been hired by the Daily Mail to find the monster in 1933, and had been publicly humiliated when tracks he claimed to have found were identified as hippopotamus footprints made with an umbrella stand. The surgeon's photograph was revenge. Wetherall, embarrassed by the Daily Mail, had created a hoax that fooled the newspaper and the world for 6 decades. The confession should have ended the mystery. It did not. By 1994, the Loch Ness Monster had become something larger than any single piece of evidence. The hoax photograph had launched the legend, but the legend had accumulated its own momentum. Thousands of sighting reports, multiple sonar contacts, decades of investigation by researchers who had dedicated their careers to the question. The exposure of the surgeon's photograph discredited one piece of evidence. It did not discredit the phenomenon. The scientific investigations had been underway since the 1960s. Tim Dinsdale was an aeronautical engineer who became obsessed with the Loch Ness question after reading a newspaper article about the sightings. On April 23, 1960, he filmed a hump-shaped object moving across the loch, footage that would become nearly as famous as the surgeon's photograph. The Dinsdale film showed something moving through the water. The object appeared to be animate. It left a wake consistent with a large body propelling itself below the surface. The film was analyzed by the Royal Air Force Joint Aerial Reconnaissance Intelligence Center, the same experts who analyzed surveillance imagery during the Cold War. Their conclusion was striking. The experts concluded the object was probably animate, not definitively, probably, but probably was enough to sustain the mystery. The Loch Ness Investigation Bureau operated from 1962 to 1972, a volunteer organization that maintained continuous surveillance of the loch, using cameras, binoculars, and human observers stationed at multiple points along the shoreline. Over 10 years, the Bureau recorded numerous sightings. The observers were not tourists hoping for a glimpse of something unusual. They were dedicated volunteers who spent weeks and months watching the water, logging conditions and documenting anything that might constitute evidence. They saw things. They could not definitively identify what they saw. Robert Rines brought more sophisticated technology. Rines was an American patent attorney and inventor who held multiple patents related to sonar technology. Beginning in the 1970s, he conducted a series of expeditions to Loch Ness, using underwater cameras and sonar systems designed to penetrate the loch's dark waters. In 1972, Rines captured what became known as the flipper photograph, an underwater image that appeared to show a large diamond-shaped appendage attached to a massive body. The image was enhanced using computer techniques that were cutting edge for the era. The enhancement revealed what Rines and his collaborators interpreted as a flipper belonging to a large aquatic creature, possibly a plesiosaur, the long-necked marine reptile that went extinct approximately 66 million years ago. The flipper photograph generated intense debate. Critics argued that the enhancement process had introduced artifacts, that the flipper was a product of image processing rather than an actual biological structure. The original unenhanced image was ambiguous. The enhancement made it look like what Rines wanted it to look like. The controversy was never resolved. Rines continued his investigations until his death in 2009, never abandoning his belief that something large and unknown inhabited the loch. Operation DeepScan represented the most ambitious sonar survey attempted to that point. In October 1987, Adrian Shine, a naturalist who had been studying Loch Ness since the 1970s and who had become the most important scientific figure in the modern investigation, coordinated a fleet of 24 boats equipped with sonar arrays. The boats swept the loch in formation, their sonar beams overlapping to create continuous coverage of the water column from surface to bottom. The operation detected 3 unexplained sonar contacts. The contacts were large, larger than any known fish in the loch. They were deep, hundreds of feet below the surface. They moved. Shine did not claim the contacts proved the existence of a monster. He noted that sonar can produce false returns, that the interpretation of underwater acoustics is complex, and that the contacts could potentially be explained by natural phenomena. But he also noted that the contacts were unexplained. They remained unexplained. The BBC conducted its own comprehensive sonar survey in 2003. The survey used 600 sonar beams deployed simultaneously, covering the entire loch in a systematic sweep designed to detect any large animal present in the water. The conclusion was negative. No large unknown animal was detected. The BBC survey was presented as definitive, the final word on a mystery that had consumed public attention for 70 years. But the survey had limitations. Sonar detects objects by bouncing sound waves off solid surfaces. It works well for locating submarines, shipwrecks, and large marine animals in open water. It works less well in complex acoustic environments where reflections, thermal layers, and bottom topography can create interference. Loch Ness is a complex acoustic environment. The steep walls, the great depth, the thermal stratification, the sediment-laden water, all of these factors complicate sonar interpretation. The BBC survey may have been correct, or the BBC survey may have missed something that knew how to avoid detection. The eDNA approach was fundamentally different. Environmental DNA, commonly abbreviated eDNA, is genetic material that organisms shed into their environment as they move through it. Skin cells, mucus, waste products, every living thing leaves a genetic trace in the water, air, or soil it inhabits. The technique was developed for ecological surveys. Researchers could sample a body of water and determine what species were present without ever seeing them, simply by extracting and sequencing the DNA fragments suspended in the water. Professor Neil Gemmell of the University of Otago recognized that environmental DNA could answer the Loch Ness question in a way that no previous investigation had attempted. The method did not require seeing the monster. It did not require capturing it on film or sonar. It required only that the monster existed, that something large and biological was living in the loch and shedding genetic material into the water like every other living thing. If a monster existed, the eDNA survey would find its DNA. In 2018, Gemmell and his team collected 250 water samples from sites throughout Loch Ness, at the surface, at mid-depth, and near the bottom. The samples were processed using standard eDNA extraction protocols and sequenced to identify the genetic signatures present. The results were announced in September 2019. The survey found no evidence of large reptiles, no plesiosaur DNA, no unknown marine reptile, nothing that matched the popular image of a surviving prehistoric creature lurking in the depths. The survey found no evidence of large unknown mammals, no seals that might have been misidentified, no unusual aquatic mammals that had somehow taken up residence in the loch. The survey found no evidence of large sturgeon. Sturgeon, large primitive fish that can reach lengths of several meters, had been proposed as a possible explanation for some sightings. The environmental DNA survey found no sturgeon DNA in Loch Ness. What the survey found was eels. Environmental DNA from the European eel, Anguilla anguilla, was present throughout the loch at every depth sampled. The concentration of eel DNA was higher than Gemmell and his team had anticipated. The eels were everywhere. This was not surprising in itself. European eels are native to Scottish waters. They migrate from the Sargasso Sea as juveniles, travel up rivers and into freshwater lakes, and spend years or decades growing before returning to the sea to spawn. Loch Ness, connected to the ocean via the River Ness, is well within the eel's natural range. What was surprising was the abundance. The environmental DNA suggested an eel population larger than expected. Eels at every depth, in every region of the loch, in concentrations that indicated the species was thriving in conditions that suited it exceptionally well. Gemmell was careful about his conclusions. He did not claim that the Loch Ness Monster was definitely an eel. He noted that the data was consistent with the eel hypothesis but did not prove it. He acknowledged that environmental DNA has limitations, that it captures only what is shedding DNA at the moment of sampling, and that rare or elusive species might be missed. But he also noted what the data did not show. No plesiosaur DNA, no unknown species, no genetic signature that could not be matched to a known organism. The environmental DNA survey suggested that whatever was in Loch Ness was not unknown to science. It was already in the database. It was eels. The eel hypothesis is not new. Researchers have proposed giant eels as an explanation for Loch Ness sightings for decades. The European eel can grow to lengths of over a meter under normal conditions. In nutrient-rich environments with abundant food and limited predation, individual eels might grow significantly larger. The sighting descriptions are partially consistent with eel morphology. Many Loch Ness witnesses describe a long, undulating body moving through the water, a description that matches eel locomotion. Some witnesses describe a creature that appears serpentine, rather than the long-necked, four-flippered plesiosaur of popular imagination. The problem has always been size. The classic Nessie sightings describe a creature of enormous proportions, 15, 20, 30 ft long. Normal European eels do not reach these sizes. The largest documented eels are perhaps 5 or 6 ft in length. For the eel hypothesis to work, the eels in Loch Ness would have to grow far larger than any documented specimen. Is that possible? The conditions in Loch Ness are unusual. The great depth provides refuge from predation. The dark water provides concealment. The abundant food supply, salmon, trout, and other fish, provides nutrition. The stable, cold temperatures at depth reduce metabolic demands. Eels are known for extreme longevity in captivity. A Swedish eel named Ole reportedly lived for over 150 years in a well before dying in 2014. If eels in Loch Ness could achieve similar lifespans, growing slowly but continuously for decades or centuries, individual specimens might reach sizes far exceeding the documented maximum. This is speculation. No giant eel has ever been captured from Loch Ness. No giant eel has ever been clearly photographed or filmed. The hypothesis remains unproven. but the environmental DNA survey provides the first genetic evidence that eels are present in Loch Ness in unusual abundance, and that no other candidate species was detected. The investigation continues. In August 2023, the Loch Ness Center and Loch Ness Exploration partnered for what was described as the largest monster hunt in 50 years, the Quest Expedition. The expedition deployed thermal imaging drones that detect heat signatures on the water surface. It also deployed hydrophones, underwater microphones designed to capture sounds that might indicate large biological activity. The thermal drones detected unusual surface disturbances. The hydrophones captured unusual underwater sounds. The findings were not definitive. The disturbances could have natural explanations. The sounds could have been produced by known biological or geological sources. But the findings were unusual. The 2024 hydrophone recordings added to the acoustic database. Researchers have been recording underwater sounds in Loch Ness for years, building a library of the loch's acoustic environment. The recent recordings have captured sounds that do not immediately match known sources, clicks, rumbles, and low-frequency pulses that could be biological, geological, or something else entirely. The Great Glen Fault is seismically active. The micro-earthquakes that occur along the fault could produce sounds that propagate through the water. The thermal vents and geological structures along the loch's bottom could produce sounds that have never been catalogued. Or the sounds could be biological. The acoustic evidence is ambiguous. Like so much evidence from Loch Ness, it suggests without proving, indicates without confirming. Steve Feltham has been watching the loch since 1991. In that year, Feltham gave up his job, sold his house, and moved to the shores of Loch Ness to conduct a continuous monster watch. He has lived there ever since. Over 30 years of daily observation earned him a Guinness World Record for the longest continuous monster hunt. Feltham has seen things. He has observed unusual surface disturbances that he cannot explain. He has watched objects moving through the water that did not behave like boats, logs, or known wildlife. He has not captured definitive proof, but he has not stopped looking. Feltham represents something important about the Loch Ness phenomenon: the persistence of human curiosity in the face of ambiguous evidence. For generations, the mystery of Loch Ness has survived not because the evidence proved the monster existed, but because it never completely ruled the idea out. Every new investigation left a small window of uncertainty, allowing the legend to live on. Yet modern science is steadily narrowing that window. Today, the overwhelming evidence points away from prehistoric reptiles and toward a far more believable explanation. One of the strongest conclusions reached by researchers is that there is no surviving plesiosaur hiding beneath the loch. The notion that a population of marine reptiles somehow escaped the mass extinction 66 million years ago, adapted to fresh water, and remained undiscovered in a Scottish lake has no credible scientific support. It is an exciting story, but the evidence simply doesn't back it up. The same applies to the idea of a completely unknown giant animal living in Loch Ness. When scientists carried out the large-scale environmental DNA survey, they searched for genetic traces left behind by every major organism in the lake. If an undiscovered large vertebrate had been swimming there, its DNA would almost certainly have appeared in the samples. Instead, the analysis revealed only species already known to science. Nothing suggested the presence of a mysterious monster. What the research did reveal, however, was something far more intriguing. Among the DNA collected was a surprisingly large amount belonging to European eels. While the study could not determine their exact size, it raised an important possibility. Loch Ness may support an unusually large or unusually behaving population of eels. In the lake's deep, dark, peat-colored water, a massive eel surfacing unexpectedly could easily appear far larger and stranger than it really is. The lake itself may also be helping to create the illusion. Because of its long, narrow shape and extreme depth, Loch Ness experiences powerful internal waves known as seeches. These underwater waves, driven by shifting winds and changing water temperatures, can create moving bulges, ripples, and wakes on the surface without any obvious visible cause. To someone watching from shore or from a boat, the effect can resemble a large creature gliding just beneath the water. Now imagine both events occurring together. A large eel briefly breaks the surface at the exact moment an internal wave is passing through the lake. What an observer sees is a dark hump, a mysterious wake, and a shape that vanishes almost as quickly as it appeared. That combination closely matches many of the eyewitness descriptions recorded over the past 90 years. Viewed this way, the Loch Ness mystery doesn't disappear. It simply changes form. It may not be the story of an ancient monster, but neither is it merely a collection of fabricated tales. Instead, it appears to be the result of several genuine natural phenomena working together. Unusually large eels, complex water movements, the lake's dark visibility, and the human brain's instinct to recognize familiar patterns in uncertain situations. This also explains why so many eyewitnesses sincerely believed what they saw. Most were not inventing stories. They witnessed something unusual, but they interpreted it through the legend that had existed for generations. Once the idea of a giant monster became part of popular culture, every unexplained disturbance on the water naturally seemed to fit that narrative. The observations were often real. The interpretation was what changed. Ironically, the truth may be stranger than the myth itself. Instead of a prehistoric beast hiding beneath the waves, Loch Ness could be home to an extraordinary population of ordinary animals, behaving in ways that have rarely been studied. The mystery was never about discovering a dinosaur. It was about understanding the lake's own unique ecosystem. The Environmental DNA Project didn't simply search for a monster. It asked a different question. What is actually living in the water? That shift in perspective transformed the investigation. Rather than chasing legends, scientists followed the biological evidence, and the evidence pointed consistently toward eels. So perhaps the famous Loch Ness Monster has never truly been a monster at all. Deep beneath Scotland's most legendary lake,